Welcome to Vision class and welcome back to this senior for mathematics and complex numbers. We are now on our next example under properties of modulus of a complex number. And example 5 says that we are given two complex numbers z1 and z2. And the first part says find the magnitude of z1, z2. Part A, magnitude of z1, z2 from the properties. This is the same as the magnitude of z1 times the magnitude of z2. So what do we do? Let us find the magnitude of z1 and the magnitude of z2. So for z1 here we shall have magnitude of z1 is the same as x squared, for which x is 5 out of 7 squared plus y. Y is negative 1. The coefficient of either is negative 1, but we are squaring it. And then you put your calculator and say 5 divided by 7 squared plus 1 squared, which is 1. This gives us square root of 1.5102. And then you find the square root of that number. This is the same as 1.2289 units. This is the magnitude of z1. And then you go on and you find the magnitude of z2. This is the same as the square root of what is z2. Z2, the real part is negative 9, which is x, but we are squaring it, plus y. Y is positive 2, which we are squaring. So what is 9 squared? 81 plus 2 squared, 85. So here we shall have the square root of 85. When you press the square root of 85, you find 9.2195 units. This is the magnitude of Z2. Now to find the overall magnitude of Z1, Z2 is now simply going to be the product of the two magnitudes. That is 1.2289 times the magnitude of Z2, which is 9.2195. Then you simply press the calculator. 1.2289 times 9.2195, and the product here becomes 11.3298 units. This is the magnitude of Z1, Z2, and that is the solution to part A. Now going to part B. Part B says that we need to find the magnitude of Z1 minus Z2. Magnitude of Z1 minus Z2 divided by Z1, Z2. We will first apply the property. This is the same as the magnitude of Z1 minus the magnitude or the modulus of Z2 divided by the modulus of Z1, Z2. Now, the modulus of Z1, Z2 or the magnitude of Z1, Z2 is already here, 11.3298. So what we just need to do is to find the magnitude of Z1 minus Z2. Remember, the magnitude of the difference is not the same as the difference of the magnitude. So to solve this, we first need to get what is Z1 minus Z2. So we need to substitute for Z1, which is 5 out of 7 minus I, but we are subtracting Z2 from it, minus Z2. Z2 has two terms. Remember how we subtract complex numbers. So we put them in the bracket so that we have negative 9 here plus 2i. And then you proceed. This gives us 5 out of 7 minus I plus 9 minus 2i. And the simplest form here, we collect the like terms. 5 out of 7 plus 9. 5 divided by 7 plus 9 is 68 out of 7. 68 out of 7. Negative I minus I is negative 3i. Now, this is Z1 minus Z2. Now, what is the value of the magnitude of Z1 minus Z2? So we need to apply magnitude on this number, which is the square root of x. X is the real part, 68 out of 7, but we said x squared plus y. Y is negative 3, but we are squaring it. So we square x, and then it gives us 94.367 something, and then we add 93 squared is 9, so plus 9. So overall here you should be able to get 103.3673. That is 68 divided by 7 squared plus 3 squared. Yes. And then you find the square root. This gives us here 10.1670, round for degrees units. Now this is the magnitude of Z1 minus Z2. So we just need to substitute for it there. So that we say now therefore the magnitude of Z1 minus Z2 out of Z1, Z2 equals to the magnitude of Z1 minus Z2 is here, it is 10.1670, divided by the magnitude of Z1, Z2, which we have already got here as 11.3298. So we shall have 10.1670 divided by 11.3298. This gives us here 0.8974 units. So this is the magnitude of Z2 minus Z1 out of Z1, Z2, and that is the solution. And now going to part C. Part C says that we need to find the magnitude of Z1 minus Z2 over Z1 plus Z2. And this is the same as the magnitude of Z1 minus Z2 over the magnitude of Z2 plus, no, out of the magnitude of Z1 plus Z2. Now, the magnitude of Z1 minus Z2, we did it in part B, and the answer was 10.1670. So we have the value for the numerator, but we don't have the value for the denominator. So now for us to find the magnitude of Z1 plus Z2, we need to say that we first find Z1 plus Z2. What is Z1 plus Z2? You come back to the complex number. Z1 is 5 out of 7 minus I, but plus Z2, which is negative 9 plus 2I. And then we collect the like terms. The real parts together, we shall have 5 out of 7. This 9 is negative because positive times negative is negative. So here we shall say minus 9. Negative I plus 2I gives us positive I. And then for you to subtract this, you need to press the calculator to make it work simpler and faster. 5 divided by 7 minus 9, and then we change it to fraction. This is the same as negative 58 out of 7, and then plus I. This is simply Z1 plus Z2. But we are looking for the magnitude of Z1 plus Z2. So we now say therefore magnitude of Z1 plus Z2 equals to, we get the square root of x. X is the real part of the complex number, which is negative 58 out of 7, but remember we are squaring it, plus y. Y is the imaginary part, coefficient of the imaginary part, which is 1, but we are squaring it. So we press the calculator, negative 58 out of 7 squared, you will find 68.6531, and then plus 1 squared is 1. So here the combined squaring and addition gives us 69.6531. 0.6531. Then you press the square root. This gives us here 8.3458 units. So this is the value of the magnitude of Z1 plus Z2. But the question part C was telling us that we need to divide. So we now say therefore the magnitude of Z1 minus Z2 divided by Z1 plus Z2 equals to, what is the value of the magnitude of Z1 minus Z2 is 10.1670, but we are dividing it by the magnitude of Z1 plus Z2, which we have got there as 8.3458. So we shall say 10.1670 divided by 8.3458, and I'm getting 1.218182 units. So this is the answer for the magnitude of Z1 minus Z2 divided by Z1 plus Z2. Let me just confirm. Divide by 8.3458, 1.2182. So this is the solution to example 5, and this is the last example we are doing under properties of modulus. In case you have challenging questions, please send them and we shall be able to address them and give you feedback. Thank you.